Dzień dobry, z tej strony Maciej Laskowski, tłumacz. Good morning, everyone. Just a brief technical reminder about the language interpretation. I will say that in Polish first. Proszę Państwa, jak już Państwo wiecie i wysłałem informację również na czacie, jest dostępne tłumaczenie na język polski. Ono jest w tej chwili jeszcze nieaktywne, ale za chwilę je uruchomimy i na dole Państwa ekranu pojawi się opcja tłumaczenia językowego albo trzeba kliknąć więcej i tam pojawiają się opcje tłumaczenia językowego, więc ci z Państwa, którzy chcą skorzystać z tłumaczenia na język polski, bardzo proszę wybrać język polski i dopiero wtedy będziecie Państwo mogli słyszeć tłumaczenie. I po wybraniu języka polskiego, gdybyśmy mieli jakieś pytania pod koniec webinaru, to proszę je również zadawać w języku polskim. Ja je przetłumaczę na angielski symultanicznie. So that was a Polish version. Now in English, you already know all the English speakers. You know that you need to select the language interpretation, select the English channel, and then you'll be able to hear any questions or interventions in made in Polish, translated into English. So I will turn the interpretation on in a moment, and we'll wait for everyone to join. And whenever Lars is ready, we can start.
Good. Thank you very much. We are ready to start. It's 1 minute past 10, and we have almost 60 participants at the moment. So welcome to this webinar number 1 in a series of 3 with the title Electrification of the District Heating Sector. The project partners are the Danish Board District Heating, it's the Silesian University of Technology, it's the Municipality of Høje-Taastrup in Denmark, it's the Royal Danish Embassy in Warsaw, and then it's Gullev DH Advisory. The project is financed by the Danish Energy Agency. We have 4 presentations this morning. One from Piotr Kleinschmidt from Forum Energii in Poland. Then we have the next one from Henning Parbo from Energinet in Denmark. Energinet is the Danish TSO. Then we have a presentation from FENAGY done by Andreas Zourellis. And not last but not least, a presentation done by Linn Laurberg Jensen from EMD International. So each of you, except Henning Parbo, you have 20 minutes, 5 minutes more for the presentation from Energinet. As mentioned, this is the first webinar. We have 2 more. The next one will be the 12th of May. Same time in the morning from 10 to 11:30, where we put focus on the different types of electricity markets. And the last webinar will be the 2nd of June, again at 10 o'clock in the morning, with practical experiences from Danish utilities. So I won't take more of the important time, so I will give the floor to Piotr for the first presentation from Forum Energii. So please, stage is yours.
Okay, can you hear me? Is everything okay? Can you hear me?
Yes, Piotr, all is well. Please continue.
Yeah? Okay, thank you. It's important to know that before the presentation. So, yes, so I will try first to share with my presentation. Can you confirm that the presentation is available? Okay,
it's fine.
Okay, so thank you very much, organizers, to invite us as Forum Energii to share some perspective from our experience. We published in last 10 years about 40 reports regarding the strategic issues with district heating. So now we are, this is the great timing because we as a Forum Energii also working about for the electrification, sector coupling and all of this stuff. And I invite everyone 20 in 2 days, 23, the 3rd of April to our webinar. So this is the great timing, but I will move to the most important thoughts for today. So first, when we look for these slides, when we talked about district heating in Poland, and then look for this map on the right side of this slide, we can see that the district heating is everywhere in Poland, in every small, medium, big cities. So there is a scale. Also, we see this dots, the red one and the green one. I would not expand it, but this is for district heating company really important because it shows what district heating companies fulfilled the efficient district heating criteria, the definition from EED directive. And this is important because it's leverage or decrease business model position to when you meet or not meet this efficient district heating criteria. This is the second largest market in Europe, 15 million end users, 400 companies. But we can say that the heating is not only the heating, because it's also, and from many years, it is right now linked to power system. And it is because of cogeneration units. In Poland, it is about 12 gigawatts electrical capacity of cogeneration units, and it creates almost 20% of electricity to power systems. So from many years, this is the important and big asset to the power system. Now, the question is how to turn this legacy into more flexible, more bankable system. When we look for the transition that happened in last years, so here on this slide, you've got the fuel mix of district heating in 10 years period from 2013 to 2023. So first, what we can see that in, of course, going from down, there is the biggest role of coal. Then the dominating fuel are the gas and biomass, some oil, and the growing role of waste, but not waste heat, heat from waste. And this is like the structure is looked like really similar over this period. It is because that the logic of transition was around decreasing local emission. So it means that it was a lot of investment, but regarding the current technology, the current fuel units. So it was the huge decrease of SOx, NOx, particular matter, but still within the existing fuel structure. But when you see, we can see that there is the growing speed of this transition, and there is a decreasing level of coal, and mostly, I would say 50-50, replaced by natural gas and the biomass. And when we look from our last strategic document, which is National Energy and Climate Plans, that was published at the end of the last year, it shows the official scenario for the district heating by 2040. So first, this VEM is with existing measure, and the second one is with ambitious measure. So as you can see, depends on the scenario. The government sees like in the next 15 years, So for district heating is not such a long time, and is maybe not tomorrow, but in today, let's say, 15 years later, that it will be the huge decrease role of coal. And the increasing role, it depends on the scenario, but natural gas, biomass, also renewable gases. This is this blue, blue is heat pump plus electrode boiler. So there is the whole group of technology. And then this other low carbon heat, it's mainly in ambitious scenario, the heat from nuclear. This is the biggest, I think, difference within these two scenario, that this ambitious scenario also sees the potential from nuclear heat. But I think that what is most important, and what how can we describe this this direction, is that we can see that we want to build as a Poland the district heating system that is, let's say, smaller in the meaning of heat demand, that it's more diversified, and I would say also more complex. And then we can see, of course, we do not know what will be the proportion of all of this fuel, but I think that this direction is clear. And at the same time, of course, district heating is on the edge of big changes, but then the power system in last year, this is a huge difference. I would say that the different system that was 5, 6, 7 years ago, and we can see with the growing renewables in Poland, there is a growing volatility. Here on the left, you can see the electricity prices on day-ahead market. That was 2 weeks ago. And so on the same day, we almost, this is like the new normality, the new status quo, that we've got the episodes of negative prices, few hours later, episodes of the high prices the same day. And with this volatility, we also see in Poland, this is something new, that we started to curtail renewable energy. So as you can see in 2000, on this right picture, in 2023, it was almost 2-3 years ago, we cannot, it was invisible, like the case that we curtail renewables. Then it really increased in 2024 and double in 2025. So it means that that there are the hours when we cannot fully utilize the renewable that are in the systems. And for district heating, it means that it's the growing importance of the period exactly when we consume or produce electricity. So and with the thing like postponing the use of electricity and heat. So it shows that the flexibility can be rewarded. And here, and here maybe this is also something important that I want to share. That I see the common misunderstanding in Poland when we talked about electrification. There is like often connected with let's simplify it, install heat pumps everywhere. And I think that that this is important, what we see under the term of electrification, because what I see is the diversification. So that this is not about using one technology. The electrification is about building a flexible portfolio. So in my opinion, it is also about electrification is strongly connected with the local heat source strategy. And what we can see on the left side of this slide, that there is a lot of sources that by this moment are not fully utilized. But then the national energy and climate plans in Poland show this direction. So we've got like the potential of wastewater treatment plant, waste heat from industrial, from data center, solar thermal, geothermal. When we combine district heating with other sector, I think that there is a lot of alternatives. Of course, not everywhere. Every case is individual. So I mean that this is just about this to build unique flexible portfolio that is that build the resilience, that build the resilience to many scenario, like high gas price, low gas price, big power price, Hormuz, Venezuela, etc., etc. So it got the many possibilities. And of course, regarding with this, together with this topic, it's important to think about the temperature of the network to make it more efficient. And just to give some number on the right side of this picture, in last year, it was many European programs that tried to map these sources, and we in Poland have around 2,000 wastewater treatment plant, and in the closest area, like 1 kilometers area from district heating pipes, there is around 300 wastewater treatment plant. And of course, probably every case will be different. We cannot utilize this 300, but this shows that that there is a lot of opportunities. Also, regarding with the ETS directive, we can map the industrial sites that are in the closest area of district heating in Poland. And it turned out that today we've got more than 100 such an industrial sites with the temperature more than 95 degrees. But to fully utilize and to see the value of such a portfolio, I think that this is one of the important change ahead of district heating in Poland. Of course, we cannot. It's always like, I know that there is 400 companies, but we need some average picture to show some things, some issues. So I think that district heating companies for many decades was built around long-term stability. I mean, long term, it was about the prices, about the cost, the fuel, heat tariffs. So in what we can see from this left slide is we've got some heat demand on this blue line. We've got this red line, which means electricity prices. We produces the heat, and parallelly electricity, just to fulfill the heat demand according to the weather condition. And to see the value of this flexible portfolio, we need to move step by step to this logic on the right side. Like so to use the benefits of this volatility, like in day ahead market, intraday market, balancing market, there is a lot of products, and it creates like many possibilities. Sometimes when the prices are high, it's good to produce as much electricity as we can, even in exceeding the heat demand. But we need heat storage to that. Sometimes when the prices like 2 weeks ago are negative, it is good to consume this electricity and get benefits by that. And this creates the millions of possibilities every day. So I think that this is the transition to day by day, to day by day creating the heating stock according to the more price market signal than the weather and the weather itself. And then so when there is the strong strategic case, we can ask why it is not happening in Poland. It is happening, but not at the full scale. And of course, we cannot, let's say that there is one barrier. I think that this is a few overlapping barriers that happening at the same moment. So first, we need to talk about if all of the regulatory, the tariffs, the financing, the subsidy, everything around, if this is designed to support flexibility or the opposite. And I think that in many cases, and here also like the scale in Poland is advantage for many reasons. But in this case, I think that the scale is disadvantage because the logic that was built for many decades and required many stakeholders, now it's creating some of the inertia of moving to this to use this volatility, because and this is in many visible in many things. So I think that this is the biggest the barrier that and then this is like the overlapping circle, I would say, because the now company has limited investment capacity. Limited investment capacity block the investment. Without the investment, we've got the high share of fossil fuels, which exposure district heating company for geopolitical risk. And because of exposure to this legislation, geopolitical risk, it stopped the investment capacity. So this is like the circle, and I think that this is important to build the mechanism that support companies in such a period in Poland. And maybe to put it in some perspective, I think that there are two main, let's say, frame. And then first is to learn this new logic of flexibility. And here I think that it's important that we've got strong CHP assets. And by this moment, this is the strongest flexibility, possibly flexibility assets in district heating systems. And I think that the natural first step to sector coupling is to learn step by step how to utilize current asset flexibly according to the market condition, day ahead market, intraday market, and specifically balancing market, which was liberalized some times ago, and then the balancing market is open for the small providers and offer many opportunities. And the second thing that we need to started to think, and it's regarding legislation, companies, financing, subsidy, started to think about electrify as a portfolio. It means like when we think about subsidy, about tariff, about connection to the grid, and the logic, day-by-day logic, operation logic of district heating companies. So these are some thoughts from our works, and thank you, everyone.
Thank you very much, Piotr. Exactly 20 minutes. Excellent. To summarize your presentation, it seems that, in your opinion, the district heating system in the future, and the future starts tomorrow morning, can be described in one word. That's flexibility. Flexibility concerning the kind of fuels you use, flexibility in the connection between the district heating system and the power system, and flexibility where you have to disconnect the link between actual production and actual demand. That means storage. So thank you very much for an excellent presentation. So I will give the floor now to Henning Parbo from Energinet. Please, Henning, you have 25 minutes.
Thank you. See if I can get my presentation online. Could you see something now?
We can see you.
Very good. Then I'll start by saying thank you for having this opportunity.
No, we can only see you.
Oh.
It's not bad.
That's okay. What happens then? No. No presentation on screen?
No.
Second. Still no presentation?
Yes, there's a presentation now.
Okay, well, then we'll start. Okay.
Yeah, fine.
Thank you for this opportunity for me to speak a little about the Danish experiences regarding the transition from a central planning system to a completely operating on market terms system, and what happened to the district heating in that context. I work with, as mentioned in the introduction, I work with Energinet, which is a Danish transmission system operator, both for electricity and gas, by the way. We are a state-owned company, and we have a workforce of around 2,500 people right now. We have, as a company, 3 main tasks. We have to operate and expand the transmission network. This is a hard task nowadays, I can tell you. We have to work for well-functioning markets. That's in the area where I work, actually. And then we have to ensure the balance during the operating day, minute by minute, second by second. And the district heating, or rather, should I say, CHP units are very important in that context. So that's what I'm going to speak about. But you'll have to have some history now, because we have discovered a major development in our system, or our structure of electricity supply, you could say. In this slide shows our production system on electricity on the left-hand side. In 1990, we had 15 mainly coal-fired production units, and on the right-hand side we have thousands of small units, mainly wind turbines and CHP units that has been brought online. And in the middle of that period, we decided to change the system from monopoly to full competitive electricity market. That what I'm going to speak about now is how we managed to do that with respect to district heating system. The development of combined heat and power production in Denmark was due to the politicians, of course. They started discussing in the mid-80s, in the wake of the oil crisis, to promote combined heat and power production. And the means to do that was to launch a so-called feed-in tariff, a time-of-day tariff on energy only in 1990. And this was profitable for investments in new CHP units. And then at a later stage, I'll get back to that, in 2005, this feed-in tariff was replaced by a capacity payment in order to better suit the market environment. And then at the same time, it was decided not to support more CHP at that time, 2005. And the incentive was completely removed in 2018. And based on this political background, I'll show you the development of CHP units in Denmark. On the left-hand side of the slide, you can see the amount of electricity capacity from CHP units, around 200 megawatts in 1990 to more than 2,000 megawatts in 10 years later, due to this feed-in tariff mainly. And the figure also shows that after the feed-in was replaced by a capacity payment and no further incentives was given, the development has stopped completely on the development of CHP plants in 2005. That's the development. And then a starting condition for this market framework, we managed to start market in late 1990, and this was, you can see now, was a starting condition for operation in the market terms. We had the old units on the left-hand side, what is here noted as central units of around 3,000 megawatts. Then we had the CHP units and wind turbines on the right-hand side that was operated outside the market. This means that all regulation and all flexible production was to be handled by central units. And this, of course, caused problems. One of the problems was that CHP units, they just produced electricity and power and heat, of course, no matter what the market price of electricity was. This means that the CHP units created so-called overload problems when the market price was close to zero or even negative, as we also experienced in Denmark. But they didn't react to that due to this feed-in tariff. Then the operation of the units, both CHP and wind power, being outside the market, created imbalances. We did not know exactly what they were doing. They were, so to speak, handling the situation by themselves, and this caused imbalances in the electricity system. And again, because they were outside the market, all regulation in order to establish balance in the electricity system had to be done from these old central units, and this was quite expensive. So we had problems at the time when in the beginning of this market area. And then the Danish government came up with a proposal that this fixed feed-in tariff should be replaced by a capacity payment, or should I better say production independent support. This would mean that the CHP plant could participate both in the spot market and regulating power market on a level playing field, and hopefully this could better the situation for the electricity system. And in addition, they made a suggestion that all CHP plants above 10 megawatts should be forced into production on market terms. This proposal was set up in 2002, and we from Energinet supported this initiative from the very beginning. And we also knew that if we were going to succeed with this, we had to do some preparatory work. And therefore we launched 3 projects in the beginning of the 2020s. All 3 projects were mainly focused on what you can call cost structure. It seems to be a huge problem in this district heating environment. They have different possibilities to produce heat from boilers and from many technologies actually, but they were not fully aware of the actual cost involved in using one or the other technology in producing. So we started one project, what it was called optimal operation of CHP plants. where we detailed studied the cost structure. I should say that in Denmark we have a quite complicated tax structure that make this work quite, how should I put it, difficult. But we develop both spreadsheets and different models in order to be better suited for this market environment, in order to give competitive bids to the regulating power market and so on. In fact, plant by plant, because the technologies differs among the different plants. In the middle of that project, which was more or less theoretical, we started a demonstration project regarding to sales on the spot market. In this project, 2 CHP plant owners participated, and some mathematicians with their models in order to test the theoretical work that has been done. And they operated a little more than half a year, where they tested something like heat forecasts, forecast of spot prices, and then the different models in order to make proper bids to the different markets. They worked in actual market, but in a manual sense, you can say. That means that the 2 CHP plant owners operated their plants themselves based on the input from this theoretical work. It went quite well, this project, so we launched then a third project, what is called the Pudel project. It's in Danish, where the main focus was to develop tools of communication and operational support for these CHP units on a larger scale. This slide shows, I'm not going to be very detailed about this, but this slide shows the communication setup that was defined during the project. What is more interesting to know is that it had participation from 30 plant owners and 5 aggregators. And at the time when we met first time, they have not, more or less, never heard about the electricity market. And we had a good discussion on which kind of information should be developed and which kind of communication tools should be developed in order to cope with this market environment, you can say. Then we had a lot of simulated testing of system, and also actual participation in spot and regulating power markets. And then as a side effect in this project, we should also evaluate the economics of CHP units participating in these different market areas. And the result of the project was quite promising, actually. We managed to develop a communication system, which meant that CHP plant could be operated remotely through an automated system. And this turned out to be very crucial, because if you would like to, as a CHP plant, to participate in a regulating power market, or balancing market, some is also called, it has to be very fast, and therefore it has to be automated all the way through. And then we made some calculation on the economics of this way of working in the market, and it turns out to be profitable for centralized CHP plants to participate. And as a consequence of this project with 30 CHP plants, we were happy to record that 26 out of these 30 plants, they continued on market terms after the project ended. And this participation in market terms rapidly increased in the wake of this project, actually. As I mentioned before, it was mandatory for the large units to participate on market terms and voluntary for all others. That was the governmental decision. And one actually happened in the beginning of 2005 was that 51 CHP plants participated in the market. It was doubled in 2 years and more than 3 times 2 years later again. So what we discovered was that through something like 4 or 5 years of operation, we went from a completely, how to put it, monopoly-based system to a 100% market-based system. And this can be seen up today because the development has not stopped. These CHP plants have improved their flexibility through investments in heat storage, electrical boilers, and heat different technologies. And today and during the 2010s, CHP units have actually been, they have a market share of something like 80% when it comes to participation in the regulating power market. That means that today they are crucial in Energinet's task to balance the electricity system. And the most, how to put this, the most prominent technology in that respect has been electrical boilers. And you can see in the slide below that we had a huge development of electrical boilers in the district heating system in Denmark. And the reason for this development has been based on many, actually many different circumstances. They started by using low prices or even negative prices in the spot market. Then it turned out that electrical boilers can also react extremely fast, so they participate in what we call FCR market, is one of the fastest and serious services. And nowadays they are earning a lot of money in participating in what we nowadays is called mFRR and aFRR market. That is, electrical boilers can participate in all kind of ancillary service that are active in the electricity market. This means that it's a very, very flexible technology, and it can also prevent curtailment, as the former speaker mentioned about. They are very active whenever we have supply of electricity due to wind and so on. So the participation in the market has brought about a lot of investments in the district heating sector, meaning that today they are, I would say, the cornerstone of the balancing in Denmark of the electricity system. And that, I think, was everything from me.
Thank you very much, Henning. I don't know if we have a question or two or a comment, then you are welcome.
I had a question. I type it in as a commentary that in Poland the major barrier to heating electrification is the grid connection capacity and the high distribution tariffs. When we talk about electrode boiler, it kills, like it don't allow in many cases to plug to the grid, and then there is no economical case because of distribution tariffs. So if Denmark has also the same problem, and how were they addressed? Or
Yes, I understand your question. Fortunately, I can say that we in 2008, I think it was 2008, 2009, that area, a new type of legislation was approved, whereby the distribution tariffs were for these electrical boilers was reduced significantly. In the beginning, it was a 4-year trial period with the low tariffs, and as it turned out to be successful, it was done permanently. So they do not pay a huge distribution tariff in Denmark.
So thank you very much, Henning. Maybe we should add that this success with the electrification of the Danish district heating sector, it's also challenging. We have some bottlenecks in the power grid at the moment because too many customers want at the same time to be connected to the power grid.
That's certainly a problem at the moment.
Yeah, it's just to be honest for our Polish colleagues that we have experienced that the success can also create challenges and huge challenges, and that means that it's a challenge to get new power lines approved by the central authorities, and it takes time. And the customers, they are maybe a little bit impatient. So that's also experience we will transfer to Poland. I think it was fair in your presentation that you also put focus on the bad experiences we have had setting up these different tariffs. They can motivate to a development in a direction which we in fact don't want. But that's what happens. We can't make successes every time. So thank you very much for a good and honest presentation.
Lars?
Yeah.
Lars, excuse me. Adam Siwek, Kempec Thermal. I have one question.
Yeah.
Po polsku. W aspekcie przyłączeń i doświadczeń duńskich, jeśli chodzi o kotły elektrodowe. U nas w Polsce jesteśmy traktowani jak normalny producent, taki jak fotowoltaika czy elektrownie wiatrowe, a w zasadzie kotły elektrodowe służą do pobierania energii, a nie wpuszczania jej do systemu. I mam tutaj pytanie, czy w Danii różnicowano te przyłączenia, to pierwszeństwo przyłączenia odbiorców, a nie dostawców energii do sieci?
Yes, I personally, I don't know. I don't know if you know it, Henning, or maybe the topic will be touched in the next presentation.
But if I understand the question correctly, I could say that all electrical boilers in Denmark are connected through what is known as a connection with reduced market access, meaning that if the grid company discovers problems in giving energy to electrical boiler, they can immediately turn it off. That's the condition that they operate. That's the reason for this reduced tariff, as I mentioned before, or reduced payment, if you like, that they have to comply with this restriction, you can say.
Yeah, this disconnection possibility. Yeah, exactly. Okay, thank you very much.
Mogę mieć pytanie, Katarzyna Graboś, Solenia Góra.
Yeah.
One question po polsku. Czy w Danii źródła ciepła w postaci kotłów elektrodowych są zaliczane w jakiejś części do źródeł OZE-owych, czyli źródła zielonego?
Not really. They're not classified, I should say. But they are used by the district heating companies that install electrical boilers. They use how to put this, a green argument because they have maybe reserve capacity on oil or something like that. And instead they built these electrical boilers also to be able to, as an emergency unit, if you like. And they use this green argument in doing that, but it's not as such classified.
I nie ma znaczenia, ile zielonej energii jest w krajowym systemie elektroenergetycznym do tego, żeby uznać jakąś część wyprodukowanego ciepła jako właśnie OZE-owego, no bo skoro w systemie macie Państwo prąd z wiatraków czy z farm fotowoltaicznych, no to jest jakiś udział tej energii wyprodukowanej jednak no, z odnawialnych źródeł.
Yes, I agree.
I czy w jakiś sposób prawo duńskie no, traktuje to jako w części przynajmniej, tak, zieloną energię? Energię cieplną wyprodukowaną z kotłów elektrodowych.
No, we don't have this expression in Danish law. We don't have it.
No, in fact, it's a little bit special in Denmark because a district heating company, they are not allowed to buy green certificates for the electricity they use. And it's because we are only allowed to include the necessary cost in the district heating price and district heating tariff. So that's a little bit tricky.
A też ja, jeśli nie wiedziałem, że też po polsku można, ale jeśli można skomentować, to ja myślę, że no u nas to jest ta pułapka, w którą dyrektywa EED też Polskę wciska właśnie w elektrociepłownie gazowe. Natomiast myślę, że w Danii to w tym momencie na etapie, w którym jest Dania, nie jest żaden problem i dlatego też być może nie jest uznawane w tej definicji, bo tam po prostu już nie ma paliw kopalnych i myślę, że tam wszystkie systemy spełniają tą definicję od dawna, więc ja mam taką hipotezę, że po prostu to nie jest jakiś case i pewnie w niczym to nie przeszkadza, bo ta definicja, wiadomo, jak ona będzie tam się zaostrzała 40, 50 rok, a teraz to tam i tak jest, one spełniają tą definicję, dlatego tak mi się wydaje, że to jest ważniejsze w Polsce i mam nadzieję, że rozwiąże to procedowana ustawa UDER 92, bo inaczej trochę Komisja Europejska stawia pułapkę na Polskę z tym definicją efektywnego systemu ciepłowniczego.
No ale może mielibyśmy wsparcie w kolegach duńskich, tak, żeby nas tutaj poparli, tak, w tej naszej przynajmniej.
Tylko, że to wydaje się, że rozwiązuje to ustawa właśnie procedowana, natomiast nie rozwiązuje z kolei problemu przyłączenia do sieci elektroenergetycznej i opłacalności ekonomicznej, bo to jest paradoks, że te systemy, kotły elektrodowe mają odciążyć sieć, a są uznawane jako jakieś obciążenie dla sieci.
Nie, my w tę samą kolejkę musimy się ustawić, panie Piotrze. I to jest największy nasz problem, a my mamy jako kotły elektrodowe i firmy ciepłownicze pomagać sieci. I nie rozumiem tego podejścia, ale taka jest nasza rzeczywistość.
Yeah, so thank you very much for good questions. We will take these challenges into the program, which will run from now on until autumn next year. So we will try to find the answers to the questions you have put here. So thank you very much for the presentation, Henning, and I will give the floor to FENAGY, to Andreas Zourellis, if you are ready.
I think I am. Thank you, Lars. Just a moment, I will just put the slide on the screen. And initially I was very happy because I think Henning gave me some spare time, but then soon I came to realize that all that was usefully used in the questions. So that's good. That's good. I hope that you can see and hear me and you can see the slides now in full screen.
Excellent.
All right, then away we go. My name is Andreas Zourellis and I am employed by FENAGY. I'm gonna just sprint through some introductory slides regarding the company. So FENAGY is a manufacturer and supplier of heat pumps, large-scale heat pumps, so to say, megawatt scale. We are based in Aarhus in Denmark. We are more than 100 good colleagues, and the company has been established 2020, and in just a few years, we have sold more than 400 megawatts of units, accumulated power. And in 2026 alone, we are estimating revenues up to 60 million euros, and we are part of a large Swedish group called BioRef. Company has been established by those 4 founders with an enormous experience of heat pump systems running with CO2 and other natural refrigerants. And I would say also that the projects we have been doing have been increasing over time. And it's not only in Denmark now that we see them, but also in other places in the Nordics and in Europe, and soon, I hope, in Poland as well. What we do, other than manufacturing the heat pumps over here in our factory, we are also providing engineering advice. We do project management of the projects that we are being involved. Of course, when we are getting the orders, we are starting up the plants, we are commissioning them, and we are always 24/7 monitoring them in case there's any alarms, and we are providing support and service to our end users. I think I don't need to go very much in detail of how a heat pump works in a district heating, let's say, environment, but in principle, as it has been stated before, it should use renewable electricity or other natural sources that are there, like the air or water sources, in order to provide heat that can either be stored for shorter or longer periods or directly injected to the district heating grid and then to the customers. And when it comes to the products, everything is skid-based. So it comes factory tested, all signals are tested, and all those units, they reflect a wide range of temperatures, not only in the source of the heat pump, but also at the sink of the district heating network. We are talking about mostly CO2 heat pumps. That's how the company was established, but later on, we have included in the portfolio hydrocarbons, which is another natural refrigerant. And just a disclaimer, we are really working only with natural refrigerants because that's how the new reality will be from now on. So hydrocarbons would be isobutane and propane in this case, and you can see the colored areas in the bottom that cover more or less every, let's say, temperature range, and you have the units next to it. When it comes to Danish district heating, of course, if we look in the rear view mirror, if we imagine ourselves driving a car at the moment, we will see that in the past we were having gas boilers, so gas engines. They still exist, of course, but in a much smaller margin. Biomass has been part of it, solar heating as well. But the new reality, if we are holding, let's say, the glass globe in our hands, trying to predict the future, it looks like a lot of renewable electricity, either than photovoltaics and wind power. And I wouldn't really say we have to forecast it because it's already existing and very well established in Denmark. And that renewable electricity gives room for electrical boilers, as it has been said before, but also electrically driven heat pumps. Of course, that wouldn't be possible without thermal storage, regardless if it is just short term or much longer term, meaning either weeks or even months. A typical CO2 air to water heat pump, which is our, let's say, bread and butter when it comes to projects and systems. A system that more or less have it all would be having a hot water storage. You would be able to see those white panels with the black dots, which are the evaporators or the fans absorbing the heat from the ambient air. Of course, all of that is controlled by SCADA and the control system, which is a FENAGY, let's say, IP or knowledge. And all of the equipment is then inside a machine room with where the heat pump units are located, and also smaller units, which we call defrosting modules, which when temperatures are really cold outside are being used in order to remove ice from those evaporators and keep them operating even in very cold conditions. There's a lot of heat pumps after 2020 that have been installed in Denmark because of a lot of funds at the start. Now I don't think this is really necessary anymore, but you can see if you get the slides afterwards and you click on that link, you will have most of them, not all of them, but most of them you can see in real-time operation all over Denmark, and you can click and see stats and facts, what source are they using, temperatures, and historical data. One of them is the project that I just showed you before, the Sonnefelling case, which has a buffer storage for a little bit more than 3,000 cubic meters, which is enough for even up to 12 days storage in the summer, maybe 40 hours in the wintertime. This plant not only has our 3.5 megawatt air-to-source heat pumps, but also has, if I remember well, a 10 megawatt electric boiler, and they are running exclusively on electricity in this plant. As the plant owner saying today, he has stopped being a heat planner as he used to be before when he was running on wood chips. He is now an electricity planner because he is only choosing when he's running up and down his equipment based on the electricity prices and very efficient use of his storage for hot water. When it comes to different air-to-water heat pumps, of course, sound might be an issue in some cases when we are close to residential areas. And in this case, I'm just using here this example to show you that this can be reduced with wind shields and wind barriers. So that's a very common method to do it. If you would ask me 3-4 years ago, I would say a 5 megawatt air-to-water heat pump is a quite big one. But we came to realize today that the new normal has become 15 or even 20 megawatt air-to-water heat pump. And there are examples at the moment in Denmark, in Billund, and you see here in the screen, and Haderslev, and there's more coming, of course. In some places, they don't have enough space for a new machine room, or they maybe need to relocate the heat pump a few years down the road. There is a solution for that. There is containerized solutions, or as we call them, enclosures that are coming ready from the factory and allow for a very fast installation of the heat pump. And then lastly, for the cases, of course, water is also used as a source. Wastewater, as it has been mentioned before, is very predominantly seen in Denmark and other places. This case example you have in front of you in the screens is for a waste treatment plant in Høje, and it uses both wastewater as a source, but air as well. So it's like a dual, so to say, source heat pump. If any of you ever visit us, and you're all welcome, if you would go to the service department, you will see a big screen that they have in front of them with a lot of dots, hopefully most of them green, because it seems it's running very well. But we have been seeing those dots or projects increasing a lot. And of course, we couldn't do that if we wouldn't have, front runners and customers that are front runners in electrification in district heating. If you take Danish numbers, we have approximately, let's say, 5 to 7 gigawatt of electricity consumption in Denmark as a peak. The installed capacity, I think it was mentioned also before in Henning's graphs, of electrification, meaning e-boilers and heat pumps together, accounts of up to 3.4 gigawatt capacity installed. Approximately out of those 3.43 are electric boilers, or close to, and then let's say 0.4 are heat pumps, and projected to increase more. Just, I think if it goes according to plans, and if there is an increase of, let's say, 0.2 extra of heat pumps, then that would keep us occupied for at least 3 to 4 years, just to give you an understanding of numbers and sizes over here. So you see how much is the installed capacity as compared to the overall consumption in Denmark of electricity for wherever it comes from. I just tried to make a little comparison here between Poland and Denmark when it comes to electrification and specifically on heat pumps. So when we are looking at district heating temperatures, of course, there are some significant differences, although that is not a limitation. I would say it's an opportunity more. So return temperatures are traditionally very low in Denmark, from 30 to 50, supply maybe from 60 to 90. And if we are focusing on air source heat pumps, the ambient temperatures are as extremely cold will be -20, and then a good summer day of +25. Of course, higher temperatures are expected in Poland for now, and a little bit harsher winters and hotter summers. Access to electricity is good, but as you have just heard before, it gets a little bit challenging at the moment. Maybe that is worse than Denmark in Poland, as I could hear it also confirmed before. When it comes to financing, it's very good in Denmark, but out of all these years, it seems that no subsidies are needed, and that in Poland that is more or less the opposite case, that we see that subsidies are needed to get project hit the ground sprinting. When it comes to matureness of heat pump market in district heating, I would say that in Denmark it's really becoming excellent, where the whole value chain is very well informed, consultants, customers. Maybe that is now ramping up in Poland, and awareness is really picking up as well. And when it comes to the business case, more than 98%, I think, of all investments in 2025 was on heat pumps and electric boilers in district heating. So that beats almost every other source based on all of these opportunities of interplaying with the electricity sector. This is, let's say, a question mark that it remains to be seen also in Poland, hopefully. When I look at the average spot prices in Poland, just yesterday when I was preparing this slide, 2025, you see here the average prices from January all the way to December. But that is a misconception that I would say, because what we really need to do is focus on specific days or hours even. So if I zoom in, I think Piotr in his slides, he was using coincidentally, I think 5th and 6th of April this year. And I just coincidentally took the 4th and the 3rd because I was a little bit more modest in terms of temperatures going negative. So, but still, that is to prove the case. There is a lot of volatility within the day. Prices can be as low as 0, but also spiking very rapidly, more than 200 euros per megawatt hour. But this is no different in Denmark. So in Denmark, we have DK1 and DK2, the two zones of electricity prices or markets. So you see on top, you have month of January in 2023. And then in the bottom, we just have one day of those. And you can see again the volatility from very low prices to very high prices again. So I would say as a conclusion, both behaviors, they look very similar. And that is to be also confirmed here with the average spot prices. You see, they're not very distant to each other. However, I was surprised to see that Poland has even more amount of hours where spot prices are negative. So that gives even more room and justification for electrification in Poland as well. So I think we're looking at the right direction over here. I think that's something also that Linn will speak about here, but I was trying to give an example of what happens in a good summer day, in a winter day. So you can see here with yellow and blue, there's a lot of green electricity from solar photovoltaics and wind power in the grid. And then you see with the light green line, that's the spot price that drops in the middle of the day. What you see with blue and yellow, this is the price for balancing up or balancing down, respectively. So you can see that there is a lot of potential for district heating utilities to participate, either regulating upwards or downwards for a marginal amount of time. So that brings a very good business case for them. Same picture that you can see in wintertime. For example, that morning, from 9 to 10, there was a very big spike in let's say in the price of on balancing up for them, for the district heating utilities. So again, that is to prove that the business case is driven a lot from reaction to providing ancillary services to the electricity grid operator. And that's just to give you the example of that specific day. If you assume that the average spot price is around 750 Danish kroner per megawatt hour, and you assume for an addition of tariff of 100 kroners on top of that, then you would have an 800 kroner per megawatt hour. If you assume for that specific plant over here that is approximately 5 megawatt with electrical heat pumps, that it has a COP of around 3 or 2.9, then you would get a heat price of just south of 300 kroner per megawatt hour. But of course, the realized price was much lower than that, almost half of it. And that was because of this opportunity for participating in the balancing markets. Of course, all of that wouldn't be possible without thermal energy storage. I think that's important to repeat. And you can see in the case of Sonnefelling how much the heat price has dropped after the electric boiler, the heat pump, and the storage tank together has been implemented. It was mentioned before by Energinet that there's also, other than the activation, I think, market, it's called, there's also the capacity market, and you're being paid for that too. So depending how many you can see in 2024 and 2025, in the different markets, the mFRR, the aFRR, and so on, either upwards regulation or downwards regulation for the two regions or zones in Denmark. You can see how many hours have been purchased just for a utility to be on standby and be able to react when it's being called for. When it comes to the mFRR, that means that there has to be a reaction time of 12.5 minutes. FENAGY heat pumps, or heat pumps in general, I would say, they can manage it very comfortably, so they can assist district heating utilities in participating in the mFRR market. What is new, or the new standard, is the aFRR market, which is a reaction upwards or downwards within 5 minutes. And that has been certified. I would show you here in the plant, in one of our latest plants in Billund. You can see here in real life how the heat pump is ramping up and down when it's been given the signal. And of course, you see in green the zone that you are allowed to be in order to be certified for this reaction response. And then, of course, you have to do it within 5 minutes, upwards or downwards. You can see here the certification for that specific plant in Billund. We are certified to do that, or for the aFRR market. And you can see here in yellow the signal that we are getting, or the district heating utility is getting, and then the heat pump operation. And then I think I will close it with saying that this would not be, let's say, possible without any, those visionary people, those 4 district heating utilities that have applied for the aFRR market, those different 4 places in Denmark, making it possible for heat pumps participating and helping balancing the grid. I think I will stop here, and then just I think the summary is that storage is essential for all of this to happen, and please choose natural refrigerants when you're thinking about heat pumps. That's important to repeat again. Thank you, and I hope I stayed in time.
Thank you very much, Andreas. To summarize your presentation, very short, when you, as a district heating company, buy a heat pump or an electrical boiler, it's not only for producing heat, it's also for selling services to the power grid. So that's a new way to work in a district heating company. So thank you very much.
You're welcome.
And the last presentation will be done by Linn Laurberg Jensen from EMD International. How can we operate this very complex district heating systems in the future? So please, Linn, the floor is yours.
Yes, I will. And you can hear me, and then I'll see if this works. You can see my screen?
Fine.
In presenter mode.
Yeah, it's fine.
Yes, okay, good. Yeah, my name is Linn, and I work at the EMD as team lead for our energy system consulting. And today's focus, as you already said, is model-based tools supporting investment and operational decision in this increasingly complex and flexible systems. I take point of departure in our own products, and I actually have 2 software solutions that I will introduce you for today, but the main focus will be on this EnergyPro, which is our solution of a software for modeling, analyzing, and optimizing complex energy systems. I myself, I have a background in consultancy, and I have worked with this software for more than 10 years, so I know what it's capable of, and that has been within district heating related projects and also projects for utilizing excess heat. I have made a short agenda, but the main point is that I will make some short introduction to both EMD and EnergyPro, and then we just launched the newest version of EnergyPro, which is 5.1. Where I will give some illustration of the use and some examples, and then I will introduce you to Victio. But first, a bit about EMD. Maybe I will not go that much into detail because we're a bit behind on time, but I could maybe say that everything we do is within the purpose of the green transition. And we have these 3 main software product which is used in different part in the energy sector. We have this WindPro for planning and visualization of large energy projects, and then we have EnergyPro, which is for decision support and optimization of these complex energy systems. And then we have what we previously called Energy Trade. We are now making a new version called Victio, which you can use in real-time optimization of your production. And again, our vision and mission is within the green transition. We are located in the northern part of Denmark, in Aalborg, where we have the headquarters, but we also have offices around Denmark, and we have agents internationally placed. We are born out of the oil crisis and was established in 1986. So we have been in this from the beginning in the Danish transition. So now I have a bit of background. Then I'll go back to the software and talk about EnergyPro. It is a software, as I said, for helping optimize a complex energy system, and it is a platform where you can build entire energy system within a single platform, and you can see the use for it here. And I think maybe only your imagination set the boundaries of what you can use it for. The software is based on a modular structure, this gives you the opportunity to customize your software package for your need in your project, and or at least, or as a minimum, you will need this design module. I have here just marked what I would use for feasibility studies, and also what module has been used in the examples that I will show you. Of course, the design, and then we also have the region module, which makes you capable of having more than one site. Then we have the market, that gives you the opportunity to have more than one market. That could be fixed tariffs, spot prices, upward regulation, downward regulation, etc. We also have the finance module that include your investments, and therefore can set a base for your overall business plan. And then we have the compare, which makes you capable of having several alternatives in one model. This is the workflow in EnergyPro, where you have the graphical interface. It is here you set up your model with all the inputs, constraints, etc. And then you go to a calculation. One of the results is the iterative plots, where you can see how your model is performing. If it's performing as expected, you can of course go back and make some changes. And when you're satisfied, you have these opportunities of reports. The point here is that it's an iterative process, and you can do this as many times as needed until you're satisfied with your setup of your model. When using EnergyPro, I think it's important to understand and remember that it's not just a simulation, but it's actually an optimization taking place, where EnergyPro determines the most cost-effective operational strategy by solving a profit-based unit commitment problem using a mixed integral linear programming solver, and we call this just a MILP solver. And in short, what EnergyPro does is it explores all possible combinations of operational decisions to find the global optimum, and that is and therefore ensuring that you have as lowest possible operational expenditure of your system. As I said earlier, we just launched EnergyPro 5.1, where the basic data structure has been updated. In this version of EnergyPro, we have moved towards a full generalized system, where all energy types in relation to markets, needs, demand, and conversion units, they are handled uniformly, and we now call them resources. So if we take a closer look into this, this is an example of a power to X model where multiple processes are happening. You can see that hydrogen is being produced from both wind and solar, and there's also a day-ahead electricity market. We have some electricity demand. We also have an electrolyzer, and here you can actually also see that water is being used as a resource. And you could, of course, if you wanted to expand your model further, you could build on a heat demand utilizing this heat rejection. And it's not because I want to go that much into detail, because this is not about power to X, but it was more to show you that the EnergyPro makes you capable of having these very complex system, and that we have generalized all the resources. Going back to today's subject, and getting a bit more into detail, we have here a system based on electricity. We have a heat pump, we have an electric boiler, we have solar PVs producing electricity, and we have electricity from an electricity market. We have an electricity demand, and we have a heat demand, and here we have a heat storage. So what you do is that you set up your reference model, and then we also call that a digital twin. And then what this compare module does is that it makes you capable of having multiple alternatives. Here is a reference based on more static electricity prices, and the other one is dynamic prices. So when you rerun the model, you could see here that the benefit for operational income lays in the dynamic prices. So this compare model was set up to illustrate that dynamic electricity prices could be a potential economic benefit. I will also just show you the graphical interface here, where you can see the electricity prices. This is just the day-ahead spot. And you have here how the heat demand is fulfilled by the heat pump and electric boiler. And you can see here the electric boiler turns on when the electricity price goes down. You can also see that it is charging the heat storage. And again here, prices go up or down. You turn on the electric boiler, and here prices go up, and then you discharge your storage. And there are several reports that are capable in EnergyPro. It could be energy and also environment, and of course cash flows. Here is a short or just a simple example of CO2 emissions, and there are several ways to do that. You could also have it as input in your left side menu. Here it is put on the electricity market, and this is just a standard value. You could also have a time series if that is needed, and you have a good data source for that. Here is another example that could have been some Danish district heating plant a few years back, which is natural gas powered, and there is a natural gas boiler and a combined heat and power unit. It is connected again to a spot market, and there you have some deliverance of heat, and there is a heat store. What was the intention in this case was the decarbonization of this plant. So here I've taken two of the alternatives that were being modeled. One was with a heat pump and another one with a thermal heat collector. And of course, several other scenarios could have been set up, but these were the two I chose here. And then from the compare module, you get this easy overview of the net cash operation from the entire system. And here it's easy to see that with the flexibility of a heat pump, this is where you have the lowest cost. And of course, maybe you could combine these two scenarios, having even lower prices. And let's see how it goes with time. Okay. Yes, thank you to Andreas for also using this. I just took this screenshot from yesterday, where you could also see there is these huge benefits in upward regulation before the solar kicks in, and again after the solar kicks in, you have these downward regulations. So you could either produce, and then you could earn money by using electricity. And this is something that is possible to model in EnergyPro. You could have it down to 5-minute time step if you wanted that. But also, what do you do in real-time optimization? And for that, I would like to mention that we have this tool, which is also based on linear optimization, but it supports production planning in real time and makes you able to activate your assets by participating and ensure bids in different electricity markets. This new tool is called Victio, and we are currently building it, and it will be released later this year. It is based on experience from our previous tool, Energy Trade, which is something that has been in the market for more than 10 years. So, yes. And going back to EnergyPro, we have these two main setup, which is creating your digital twin and the comparison reference, and then you have the opportunity to build potential future digital twin and compare your scenarios. And a few concrete example of how to use this tool. It could, for instance, be a completely new system where the project is to design and define all capacity, etc. It could also be an existing system which you wanted to decarbonize. Could be in having more units from electrifying units, heat pumps, electric boilers, and it could be renewable energy technologies. It could also be increasing storage units, and it could be changes in heat demand, for instance, if you wanted to expand your district heating grid. And then again, we see EnergyPro used for sector coupling. Previously, it has been mentioned there is this large potential of excess heat from, for instance, wastewater, but also industrial sites. And then I think it's also increasingly about market changes. Prices are becoming more volatile, and therefore there also is a need for robustness and resilience in the system that we see a growing need of and a need to analyze. So the point is that you can test all these scenarios and compare consequences before you are making your decisions, and that is something that EnergyPro can help you with. But yeah, I think I'll stop here. I put my contact details in the last slide, and you're of course welcome to reach out.
Good. Thank you very much, Linn. Just one small question from my side. Is it possible on your homepage to get access to a test version of EnergyPro? So
Yes.
Our colleagues in Poland can see
Yes.
the benefits they can get.
Yeah, they can go in and have a demo version of it. And if they wanted to have a trial, we have, I think it's a 2 weeks trial version if they send an email to our sales department, and it's just sales@emd.dk.
Okay, good.
Yeah.
Thank you very much. And thank you very much to all the speakers at this webinar. If we have any questions in the chat which we haven't answered yet, we will pick that up, and then you will have the answers later in a mail. After acceptance from the speakers, we will also send out the presentations to the participants in this webinar. So I thank you, the speakers, and also the audience. We have still 64 left. That's fine. And then I hope to see you all again at the next webinar, the 12th of May, 2026 at 10 o'clock. So thank you very much.
Thank you.
Thank you. Bye.
Thank you.
Bye.
Bye-bye.
Thank you.